Alright, welcome to what I call the if-diff method. So this is a method that we're going to use when the inner function of an integral is not linear and the derivative of the inner function, which by the way we call this the diff, alright, and then the inner function I'm going to refer to as the if. But we're going to use this when we see that the derivative of the inner function, or part of it, shows up in our integral. So, what am I talking about? Well, here's an example. And notice here we have the 6x to the fifth times the cosine, and then within that cosine we see x to the sixth. So this x to the sixth here is what I refer to as the inner function. Again, sometimes we refer to it as u. Later on we're going to be looking at a technique called u substitution, where u will represent the inner function. But for now we're just going to keep it a generic if for inner function. Well, notice that off to the side here is the derivative of the inner function, or the diff, right? Because the derivative of x to the sixth is 6x to the fifth, okay? So what we're going to do here with this technique is we need the diff to show up, all right? And it does. We see it's 6x to the fifth. So what we are going to do is I encourage you to just put a single line through it. Don't scribble it out. We want to be able to still see it. All right, but that indicates that we are not going to bring the diff along as part of our answer. So instead, what we're going to do is we are going to integrate the outer function, which is cosine. We know that when we integrate cosine, we get sine, and then we're always going to carry along the inner function. Okay, so this would be our final answer. Now, think of this as being equal to y. If we were to check this, all right, if we were to find the derivative, okay, it's important that you understand why this technique works. If we find the derivative of this, we would have the cosine of x to the sixth. Once again, the inner function would come along for the ride. And then recall that the chain rule said that we would have to chain along the derivative of the inside, which would be 6x to the fifth. And notice how that matches what we started with in the integral. Okay, so here we're just working backwards. All right, so it's important to make note that the diff stays behind and does not come along as part of your answer. So let's write that down. Alright, so there you go. Let's look at another example. Okay, next example here. Notice there's a big square root in it, and when you see a square root, typically we want to rewrite this as a 1/2 power, so we want to get rid of the square root. So I'm going to just copy this all over. Notice how I'm not dropping my integral or my dx. Okay, and so from this point, you have to figure out, okay, what is the inner function? What is the derivative of the inner function? Well, if you're thinking that 8x plus 3 is your inner function, that would be wrong because its derivative would be 8. That does not show up anywhere in the problem. However, most of the time your inner function is going to show up as the base beneath your power there. So this is my inner function, and notice how if we take the derivative of 4x squared plus 3x, we're going to get 8x plus 3, right? So this is my diff. So again, please get in the habit of just drawing a gentle line through the diff as a reminder that we're not going to bring that along as part of our answer. So now at this point we're going to integrate the outer function. Well, the outer function is this 1/2 power, so we're going to need our power rule. So this says, remember, we're always going to carry along our inner function. So we need to do our power rule, which says to add 1. So when I add 1 to a half, I get 3 halves. And then dividing by 3 halves would be the same as multiplying by 2/3. Okay, so that is our final answer. And keep in mind there is no chaining along a 1 over the derivative of the inner function. That was only when the inner function was linear. Okay, so we're not doing that technique here. Okay, and again, it's wise to at least do a mental check. If we were to take the derivative of this answer, 3 halves multiplied down to the 2/3 will give us 1. Subtract 1 to your power, your new power is 1/2. Okay, you would have the 4x squared plus 3x on the inside, so now we're looking at this piece right here, and then you would chain along the derivative of your inside, which would give you that other piece. Okay, so at least check it mentally. Okay, here's our next example. So what you have to understand is that quite often in these problems we're going to need to rewrite things in a different form. So what this is really giving us is the natural log of x, the natural log of x to the fourth power, so that whole quantity, and then times x. And then we can take this a step further. This is really 1 over x times ln of x to the fourth dx. So what I did there is I just separated it so that it's a little bit easier to see where the inner function is and where the derivative of the inner function is. So again, most of the time your inner function is going to be the base of a power. So we see that power of 4. So the inner function is the natural log of x. And notice how its derivative shows up next to it. All right, the derivative of the natural log of x is 1 over x. So from there, we ignore the diff, and then we're going to apply our rule. So we have an inner function raised up to a power of 4. So this is our power rule. We bring along the inside piece. We're going to add 1 and then divide by that new number, and then this would be our final answer. All right, next example. Notice how we have t's in this for our independent variable. So we don't have a dx, we have a dt on the end. And so just like the last example, you want to think about how you can rewrite it. You want to separate the parts as much as possible. So we have this 8 cosine of t. Okay, if you want, you can put parentheses around it just to kind of organize it. And then we have this 2 plus the sine of t. In the bottom, it's raised to the positive 3. So if we bring it up, it's now raised to the negative 3. And we still have our dt there. Right? We have not integrated yet, so don't remove your integral or your dt symbol. Well, from here, it's a matter of saying, okay, where is the inner function and where is its derivative? Well, like we said before, the majority of the time, the inner function is going to be the base of that power that you see in the problem. So the derivative of 2 plus the sine of t is just going to be the cosine of t. Well, notice how we have this 8 here in front. Well, we can take this 8, since it's a constant, and we can just move it out front there. Okay? And so really this piece right here, just the cosine of t, that is our derivative of the inner function, right? Remember, the derivative of 2 is 0, derivative of sine is cosine. Okay? So the diff piece does show up. All right, now that 8 we are not going to leave behind. All right, the cosine of t, or the diff piece, we will leave behind. All right, so we have that 8 times, now my inner function is 2 plus the sine of t. Because we have a power here, we're going to use our power rule. So we're going to add 1, so be careful, we're getting closer to 0. All right, it's not going to be negative 4, it's going to be negative 2. And then we need to divide by that new power of negative 2. So our final answer here would be negative 4. And then let's take this 2 plus sine of t and throw it in the bottom as a positive 2 there instead of expressing it with a negative power. Okay? And then we, of course, have our plus c. Alright, so the next question is, what if only part of the diff shows up and not the entire thing? Well, what we're going to do is we're going to make it show up. We're going to force it to show up, and then we're going to balance out what we did so that we're not changing the problem. Now, please beware, this can only be done with constants, not variables. So we can insert constants into the problem, or numbers into the problem, all right, but we cannot insert variables, all right? So if we take a look at this example here, it'll show this concept. So we have 8x times e to the x squared. So usually when you have an e function, your inner function is going to be its power, okay? E is the main function, or the outer function. Its inside is x squared. And notice how part of the derivative shows up. All right, the derivative of x squared we know is 2x. Well, we have 8x. So what we're going to do is we're going to rewrite the problem, and I'm going to have you ignore that 8x for a moment and just write down e raised to the x squared. Okay, we mentioned that this was the inner function. And what we're going to do is we're going to force the derivative to show up. So the derivative of that inner function would be 2x. So let's just make this clear that this is the diff. All right, we forced it to show up. But I just changed the problem. I changed it from having an 8x to a 2x. So I can't do that. I need to balance out what I've done. So you got to think about, okay, what do I need to multiply this by on the outside in order to turn this 2x back into the 8x? Well, hopefully you're thinking 4, because 4 times 2x gives us that 8x. Okay? So let's just jot something down here. Okay, so we want to rewrite this with the diff that you need and then balance it out. So that's what we did in that step there. Alright, so from here to finish this up, again we said we're going to ignore that diff piece. The 4 in front is not going to be ignored. That must come along for the ride. So then we have e to the x squared, because remember when you integrate e to anything you get the same thing back. Okay, and then we would have our plus c. So this would be our final answer. And again, just do a quick mental check. Alright, think of this as really equal to y. If we were to find the derivative of this, we know that we get the same thing back when we have an e, right? E for easy. And then we would have to chain along the derivative of the inside, which would be 2x. And notice how that gives us 8x times e to the x squared. So that's just a check. Do you have to do the check? No. But certainly in the beginning you want to, I would suggest mentally be going through that process to help you understand why this technique works. Okay, here's another one. We have 2x times, and then you see this 7x squared plus 3 raised to the 6. Again, notice how the inner function is not linear. Okay, this is our inner function, right? Usually, again, the base of the power here is going to be your inner function. So we can see that it's clearly not linear. So 7x squared plus 3, that has a derivative of 14x. So we can see that there's a multiple of it next door, all right, right beside it. So what we're going to do is we're going to rewrite this. And again, I haven't actually integrated yet, so I still have my integral and my dx. And we're going to force the diff to show up. Well, the diff should be 14x. And I really want you guys to be in the habit of labeling these key parts like this. Okay, it helps you avoid making a mistake. And again, put a line through that diff as a reminder that we're not going to need it. But hang on, we got to figure out what we need to do to balance this out, because I just changed this problem. We went from having a 2x in it to a 14x. Well, I can't do that without balancing it out. So what would I have to do to that 14 to turn it back into a 2? Well, I'd have to divide it by 7 or multiply by 1 over 7, right? So if we multiply those together, excuse me, the net result would be 2x. So the 1 over 7 comes along for the ride. The inner function always comes along for the ride. And then because we have a power here, we're going to use our power rule. So we would add 1 and get 7 and then divide by that 7. So that's going to give us 1 over 49 times this quantity to the 7th and then plus c. Alright, here's our last example. Let's, how about you guys hit pause and see if you can do this on your own, and then hit play to see how you did. Okay? Hey, you didn't hit pause. Come on, try it on your own. Do it. Alright, here we go. So, assuming you did this, hopefully, there's our inner function. And it's okay too, guys, if you don't feel like completely rewriting it. If you want to just say, all right, what is the derivative of the inner function supposed to be? It's supposed to be a 6x. So if you just go ahead and put a 6 there, that's fine. All right, this is now giving us the diff. And certainly if you have a different color, it's helpful to use. All right, so then what are we doing here? What do we have to do to balance this out so we're not changing things? Well, we would have to multiply by 1 over 6 because we know that we started with just a plain x, right? So again, you could just do this with the original problem if you would like. You don't necessarily have to rewrite it, but it certainly wouldn't hurt. All right, so we have 1 over 6. Our outer function, our main function, is cosine, so that's what we are going to integrate. So we know that the formula for integrating cosine is just sine, and the inner function comes along for the ride. We slap on a plus c. Okay. If you were to check this, again, pretend this is y. All right, this is our answer, but if we were to check it, the derivative of this, that 1 over 6 would stay there. The derivative of sine is cosine. Bring the inner function along, chain along the derivative, you'd have a 6x. Notice how the 6x and the 1 over 6 will just simplify to x times the cosine of 3x squared. Okay, so that shows that it checks. All right, it's always wise to do that. Bye-bye.